Hello, so we're back, and this time we have a proper nice laptop to repair. This is a Lenovo Legion 5, and we have a long story from the customer. Let's read the customer email. So what the customer is saying, the laptop is not working anymore. He tried to diagnose the problem. He checked the charger is working, the battery. So laptop worked with the battery charge. Then when the battery was empty, the laptop didn't start anymore. So the customer, it's assuming, can be a charging issue. Now he tried to reset the laptop, he tried with another adapter. He's thinking it's a problem on the motherboard, and he is believing it's actually a MOSFET being faulty. So based on what the customer is saying, this laptop should work if we are charging the battery. I would say let's open the laptop and let's have a look inside. Now it will be the first step, charging the battery to see if the laptop is working. If the laptop is working, then we're gonna try to diagnose the charging circuit. Now this particular customer is from Germany, but he said I can post the laptop back into the UK, so it's fine. Usually I don't, actually I can't take jobs from outside of the UK. What is strange is I have more job requests from Europe compared with the UK. And the laptop is open. Yeah. We have a seal on the motherboard, so no one took the motherboard out. That's crazy. I mean, check the fans. I mean, wow. Because people ask, okay, Sarin, but how a gaming laptop is dying? Yeah, like that. I mean, it's not about this dust, yeah? I mean, it is about even this dust, but here you can see on the front of the heatsink, it's a lot of dust. Check here. So that's how the gaming laptops are dying. They're getting hotter and hotter, and yeah. Yeah, we're gonna clean the fans and the heatsink, but let's try to figure it out what's wrong with the laptop. So, do you think we should check the main power rail? No. Yeah, let's check the main power rail. So the main power rail voltage. So the battery voltage is 0. Okay. Main power rail voltage looks like it's 0. Let's check for short. So the main power rail, 23 ohms, 1 ohm. Not sure if here is the main power rail. Maybe here? Here is not short. I mean, this is a power supply, but not sure if here is the input of this power supply, because 12 ohms is very low. You know what? Let's be sure. Because if we have 12 ohms, must be some MOSFET or that power supply. You know what? Actually, here is the input on that power supply. Check that. I mean, why we have 25 ohms here? Let me unplug the battery, but the battery has 0 volts anyway. Okay, the battery is unplugged, and we still have 24 ohms. You can see on the screen. Yeah. No, that's not good. No, that's not good. Let's take out the heatsink to make some space. 25 ohms, it's a partial shorted chip, partial shorted capacitor, partial shorted MOSFET. Partial shorted stuff are more hard to be found. I mean, yeah, it is. It's a lot of dust into the heatsink. I mean, even here, check here. This is all clogged. Check here. Yeah. Yeah, that's the reason why the laptop died. Yeah, of course. Now I know on this channel are, skilled people. But no, a usual customer, a normal customer, they will never open the laptop. Wait 1 second, because here we have something also. Yeah, check here. Wow. So this laptop definitely was extremely slow, if not shutting down when the customer was playing games. Good. Now we have access to more stuff on the motherboard. Uh, Here we have capacitor, 0 ohms, 23 ohms. Okay, that's great. So I'm gonna come with the power supply with low voltage. Yeah, 1.3. Should be fine. Ground. Thermal camera. And hopefully we can see something with 25 ohms. It's very high resistance. Yeah, thermal camera is on. Actually, you know what? It's not even point coming here. I can come here because we have like a big test point here. And it's taking like 50 milliamps, 60. Quite low. What is taking 60 milliamps? You know what? I have no idea what is taking 60 milliamps because nothing is getting hot. Nothing. No, nothing is getting hot. Okay, that's strange. Of course, something is partial shorted because you can't have like 25 ohms on the main power rail. Let me take this metal bit out. If the customer is right and the laptop is working with a charged battery, then what can be shorted can be like actually the BQ chip. Yeah, because it's connected to the main power rail, so can have 25 ohms. And also when it's faulty, the laptop it will not charge. The SSD it's out. Let's check one more time. So it's taking 60 milliamps. And nothing is getting hot. That's crazy. Let's raise the voltage. Okay, 150 milliamps. 150 milliamps, definitely. Check there. We have some heat from here. But it's coming from the back of the board, and that's bad because here somewhere is the EC chip. The customer said the laptop is working. Okay, let's take out the motherboard. I mean, on this case, let's say the EC chip is dead. What can be faulty? It's actually the LDO power supply being shorted. But the main issue is not the EC chip. I mean, probably the EC chip is dead. Let's say, yeah, let's say it is possible to be dead. Our concern is actually finding what is partial shorted on the main power rail. So let's not get lost and going on a rabbit hole. Let's focus on the main issue. So what is the right approach for a normal customer? Let's say if this customer is using a compressed air can, it will solve the problem? No, it will do even worse. Because if you use some compressed air, obviously a normal customer, it will not open, the laptop, the heatsink. If you use compressed air, you will push the dust into the fan and the fan, it will stop working. So what is the right approach? The right approach is to clean the laptop preventive, yeah? So if you like one time per month, you use like a compressed can, then nothing wrong can happen. And the laptop, it will never overheat. And the first stage of overheating, it's a slow CPU, slow laptop. I mean, yeah, you will hear like the fan spinning fast and all the stuff. But mainly the speed of the CPU will go down. What is there? Check there. What is that? What is that? You can clearly see it's blow up. I mean, even here, you can see it made like a hole on the keyboard. Let's check together. Yeah, you see exactly what I told you. BQ chip circuit, and this is the high side MOSFET, which is shorted. And it's exactly on the same spot where we seen heat. We seen heat here, but on the other side of the board, here. Yeah. So the customer it is, right? Probably the laptop it is working with a charged battery. So how we are fixing something like that? I mean, this MOSFET clearly it's welded to the board. We have some burn layers here, but overall it's looking good. Yeah. Let's try to take this out. And yeah, check here. Wow, this is so beautiful. I mean, this is the drain of the MOSFET. Good, so here we have the gate. Check here, we have the gate here. And we have the source. I mean, it's not that bad, right? I mean, yeah, if we are ignoring the burn layers, I'm assuming this is what has 25 ohms, the burn layers. But it's looking good. Definitely it's looking good. Let's clean it. Alcohol. Looking good. Yeah. No, I don't want to break the tracks because we can use, I want this pin out. We can use some UV gel, yeah, just to fill up the area here, which is clean. You can see here is no burn layers, so it's looking good. I want this thingy out. Good. Yeah, so let's use some UV gel here. Then we can settle all the things back into the place. The second MOSFET being shorted, probably not, but we can check that. The second MOSFET, it is shorted, lol, 1 ohm, check that. So the second MOSFET, it is shorted. Let's take out the second MOSFET. Also, the BQ chip can be dubbed, yeah, can be. Okay, the MOSFET is out. Let's check one more time. Yeah, it's not short anymore, you can see, no short. Good. Good. Perfect. Let me bring some UV gel here. Yeah, that's all what I want there. Let's use a toothpick. We have UV light here. And everything is looking fine there. Good. Let's put this back. Perfect. This. Perfect. Let's clean it. And we have the gate here. But the gate has the pin attached. I'm gonna try to cut down that pin. This one. And success. Yeah. Good. Let's come with some rosin, solder. This is the source of the MOSFET. Perfect. I don't want to clean it because it's only Flux and solder. Let's find two MOSFETs. Let's solder the MOSFET. Perfect. Now let's be sure every pin is soldered. Yeah, the gate. Our gate. So our gate is soldered, and the source. I mean, we have a pin, but all pins are together. So even if we are soldering one pin, and we'll still be fine. We have two pins here. Two pins is fine. All pins are connected together inside the capsule anyway. Let's check with the multimeter. So with the multimeter from here to here is fine, no short. You can see gate is fine, no short. So what do you think? The first question is, what about the main power rail? We still have 25 ohms. So we have ground, and we checked where? We check here, and it's not 25 ohms anymore. Let's put the board back and let's do a test. Not sure if it's charging. I mean, you can have a faulty BQ chip there. So the board is back in place, yeah? Let's plug a charger. Probably it will not work with my power supply, but we can try it. Lenovo square pin. We need like 19 volts. 19 volts. Plug in the charger. 10 milliamps. No short. Not charging. Yeah, that's possible because the battery is very dead. But we can help the battery, right? We can. So the battery is not plugged in properly. And the battery is charging, the battery is dead. Why is short there? Wait, I seen 2 volts. I seen 2 volts, right? Why 2 volts on the battery? Hey, 1 second. So on the battery we have 0 volts. The main power rail is 0 volts, 0.8. Yeah, that's because of my charger, but 1 second. 1 second. Why? We have like 2 volts on the main power rail. The main power rail is not shorted. Wait 1 second. How this is possible? So the main power rail is not shorted. Yeah, I'm coming with 13.8. But on the battery on the plus, the voltage is down to like 2.8 volts. Because the battery is short. No. No, the battery is not shorted. Something is still short here. So here on the plus, check there. The voltage is getting dropped to 3 volts. It's already dead. Yeah. The low side MOSFET is shorted. Is shorted or is triggered by the BQ chip. Unlikely. Yeah. Okay. So I know for sure my power supply it will not work to charge the laptop. But we have here some chargers. So our dodgy MOSFET is good. The other MOSFET is the problem. So here, checking DC ground, 3 ohms, you can see, 3 ohms. Because this MOSFET is connected to ground. Wait 1 second, what is this? Wait, what is this? Ah, lol, this was the low side MOSFET. The low side and high side. Why this is shorted? Because this MOSFET died. Here we have 3 ohms. This is dead. How the MOSFET died? Hey, that's a good question. Okay, the MOSFET is out. Shorted MOSFET. Yeah, 2 ohms. Here is no short. No. Let's pick up another MOSFET. And the solder. Yeah. Good. If it's getting shorted again, we have a dead BQ chip. But you know what? This is the first time I'm finding a low side MOSFET being shorted. I never found low side MOSFET being shorted. Yeah. So this is new. Because obviously the low side MOSFET is, switching the coil back to ground. So it doesn't have that much voltage or current. But yeah, this one was dead. Good. Let's see, with 19 volts. Yeah, we can do the test. If we have voltage on the battery connector, does mean something is wrong there. 10 milliamps. But I said my charger is not good. So my charger has 0 volts on the main power rail. Yeah, I don't have a charger ID pin here. But what I can do, I can check like low voltage on the plus. Is gone. You seen that? The MOSFET just got burned now on this second. It was like kind of like low current and yeah. Yeah, the big chip is dead. So if I'm checking now the MOSFET is shorted. Yeah, 0 ohms. The gate is shorted also. I'll take the MOSFET out and I'm gonna check if the gate is connected to the big chip. If the gate is connected to the big chip, we're gonna replace the big chip. Good. So here is no short. Then the gate from here. Yeah, check that. 0 ohms. So the gate it is connected to the BQ chip. Okay, let's replace the BQ chip. I'm pretty sure we can find like a brand new BQ 24780S on my box. Perfect. Let's see. Actually, you know what? I do have brand new chips here. It's fine. We're gonna find a brand new one here. Wow, check that. A brand new BQ chip. Huh? So we do have, yeah, brand new, absolutely, yeah, definitely. Okay, it's looking, looking bad. It's looking bad, but let's clean it. Okay, it is clean. Let's apply some solder. Looking great. Pin number 1 is there. I'm gonna dip the chip into the rosin. Perfect. So the chip it is soldered. We have a small bridge there. I can see it. Yeah, looking good. Now let's replace that MOSFET again. Actually, let's replace both MOSFETs. Perfect. Every pin is soldered. Yeah, the gate looks fine. Looks like it's soldered. Good. So what about now? It will work or not? I think the best test is to come with the power supply on the battery connector. That's the best test. So if we're coming with the power supply at the battery connector, minus plus, and it's taking no current, nothing, you can see. Yeah, we can higher the voltage. Yeah, like that. Battery connector, nothing. Check that, nothing, no current. Yeah. Now it is working. Plug in the charger. Yeah, let's plug the charger. Probably that's why it was not working. So we need 19 volts, 20 volts. Yeah, it's fine. Plug in the charge, and the board started. Check that 1 amp. Wow, the CPU is proper hot. Ha! Can't believe. Let me bring the laptop back. So what is the solution to prevent that this kind of faults or any kind of fault on a gaming laptop? The solution is, always replace thermal paste and keep the heatsink clean. Because a big part of the cooling is actually using the motherboard. A lot of components are using, like every MOSFET, the CPU, the GPU, it's using the motherboard to cool down. So if you have like clocked fans, the overall motherboard temperature is rising, and electronics and heat, they are not going together. Especially the components which carry like high currents, like MOSFETs. Yeah, so keep in mind, air can, try to have the laptop on, the fan spinning, and use the air can on the heatsink, and keep the heatsink clean, even without opening the laptop. Overheating job, it's a big pie on a computer shop, yeah, and it's including replacing the thermal paste, cleaning the fans, greasing the fans, cleaning the heatsink. And that's about the same price like with a Windows installation, about 50 to 60 pounds, depends of the laptop. So yeah, if you can't do it and you don't want to touch the laptop, yeah, you can go to a computer shop and they can do it for you. Now I'm curious if the laptop is charging. We didn't check if it's charging. So I'm gonna plug the battery. Looks like the laptop it is working with my charger. Plug in the charger. 180 milliamps, that's the pre-charge current, and 1.3 amps is the charging current. And the laptop is coming on also, right? Yeah, it is coming on. Let me shut down the laptop. Okay, the laptop shut down anyway, probably because of overheating, because we don't have heatsink. Yeah. And it's not charging. Yeah, 180 milliamps. Yeah, it's not taking current, but we have the charging light here. So I'm gonna come with the power supply, same like before. And check there, the battery is charging with 2.3 amps, but the voltage is the battery voltage. Yeah. Remember when we tested the first time, the voltage dropped to like 2 point something volts. So now I'm expecting the laptop to charge. Let's wait. And the laptop is not charging. It's taking like 180 milliamps. It's going to 180, then it's switching back to 20. You think the battery is fully charged actually? $12.3, and it's supposed to have 15.4. Yeah, it's still low. The battery is still low. Let's help the battery. Yeah, it's taking like 2.3 amps. Let's wait a little bit. Okay, the battery took some current. Let's see. Oh, plug in the charger. Not charging? Why? So we are like few days later. The charger is plugged into the laptop. Let's check the charging because this is a genuine charger. On the battery, we have 14.9 and the voltage is going up, you can see. So clearly the laptop it is charging. Now going and pressing the power button, the laptop it is coming on. Loading the windows. And everything is fine. We have the charging sign. The laptop is working fine. Now, just to understand, I will tell you the long story short. Yeah. So the long story short, I work on this laptop till the point was fixed already. Yeah? The point we replaced the BKG, we replaced the MOSFET, so it was fine, but not charging. I work at least 3 hours more, and this is kind of like a human error. It's called confirmation bias. I was so convinced actually that it's an issue with the charging circuit because the charging circuit it was faulty. It made me replace like the chip again. The MOSFETs I replaced it twice. I replaced it probably like 3 times. Then I checked every component. I checked every voltage, every current with and according with the data sheet. Till the moment, I just went outside after like 3 hours of work, just to understand. Went outside, smoked a cigarette, and you know what? I work 4 hours. I never seen picture on this laptop. I mean, the laptop has like a charging. I can see it's not charging, it's taking no current, but we are getting some error, like charging error, charger error, or something. Because I knew from the beginning I don't have the charger ID. I do have the charger ID, but this one need like a chip on the inside of the charger. It doesn't work with resistors. So I test with a genuine charger, and I'm going to show you the charger. And this is a genuine charger, 135 watts. Okay, maybe it's less power than the laptop need, but should charge. Well, no really. On that moment, after I spent that time, I put everything back together. I powered the laptop saying power adapter is not the right one. Then I went to eBay and I bought exactly the charger this laptop needs. So I pay like £35 and now we have a 170 watts charger. And of course, with this charger, it is working. Unbelievable. I'm going to show you the charger. The charger just arrived today. Yeah, with this charger, it is charging. But what is insane is this, what is called confirmation bias. Just because I knew it will not gonna work without a proper charger. I knew that from before, and we spoke about the charger I dip in so many times. I'm trying to let the people know, because many they think you use some resistor and it will work. It will not gonna work. Has a complex IC inside of the charger, which is speaking with the motherboard, with the EC chip, and I knew that. But still, I spent like over 3 hours trying to diagnose and repair the charging circuit. I mean, this is so stupid. I can't even show you like how much I work on, but probably I have the timestamp. 1 second. So this is the recording video without editing. So this video has 2 hours and 36 minutes, but the video was paused. I paused the video many times. So it was over 3 hours. I mean, this is crazy. You know, we are doing some stupid mistakes. This was a proper stupid mistake. And it is my fault because when the customer want to send something, on the text I'm sending, with the address and everything, I'm saying don't post your charger, because if the people post their charger, it's not only the package more heavier, but it's kind of pointless because I have most of the chargers. Yeah, I don't have the Lenovo this 170 watts one, but I have most of the chargers. And also there is a risk, that the customer charger get mixed with my charger, and yeah, I prefer for the customer to not send the charger. Anyway, the laptop is repaired. Try to learn from my mistake and don't do the same mistake. Try to get like a solid base of chargers, genuine chargers. Yeah, that's very important. And you keep that charger only for testing and only for repairs. Okay, I'm happy I helped the customer. I'm gonna stop now. This is a lucky customer, it is, because we have like a blow up MOSFET on the charging circuit. We could have like on the CPU, on the GPU. Anyway, I didn't replace the thermal paste because this is the Honeywell pad, but I cleaned the fans, I cleaned the heatsink, everything is like new here. So it is a lucky customer. I'm gonna stop now. I will say thank you for watching. Like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.